Hello, good morning. This is Professor Grenfell once again, doing another video lecture for Chapter 11, Section 1 on the chi-squared goodness of fit test, or the test for goodness of fit. And so for this example, we're going to be looking at example 11-3, talking about firearm deaths. And it says a researcher read that firearm-related deaths for people aged 1 to 18 years were distributed as follows. 74% were accidental, 16% were homicides, and 10% were suicides. In her district, there were 68 accidental deaths, 27 homicides, and 5 suicides during the past year. At alpha equals 0.10, test the claim that the percentages are equal. Or, well, I think what they should say is fit this above described distribution. So let's see, the first thing to do would be to look at the sample size. So we've got 68 plus 27 plus 5. And thankfully enough, I think that adds up to exactly 100. We just should double check this with a calculator because I often do this part wrong. All right, no, I think that works out. Okay, so that's going to be our sample size. This is going to be n. And notice there are 3 distinct categories. So k is equal to 3, and that's going to be used to find our critical value. Now, in the previous video, I kind of waved my hands at, well, arguably the important part. In a hypothesis test, we always have to state the hypotheses, and I'll keep it simple and say that the null hypothesis is that the observed distribution fits the above stated distribution. In other words, 74% accidental, 16% homicides, and 10% suicides. And then the alternative hypothesis, H subscript 1, is that the observed distribution does not fit the expected distribution. Okay, in step 3, that's where we're going to break and jump off of this page to a spreadsheet to aid that calculation for the test statistic. But before we do that, I'm just going to look up on my table and then, maybe just show you again what the critical value is. So here's a little sketch of the chi-squared distribution. The degrees of freedom are going to be k minus 1. And remember, k was equal to 3. So here we're looking at 2 degrees of freedom. I'm just peeking at the table of values for 2 degrees of freedom at alpha equals 0.10. The critical value is, if I'm reading this right, 4.605. So that's the cutoff score above which we would be in the rejection region. Below that, that would be the non-rejection region. All right. Now, step 3 is we're going to compute the test value. So I'll just remind us how we do that computation. The chi-squared is going to be the sum of all of the observed frequencies minus the expected frequencies squared divided by the expected frequency, the expected value. Okay, so that means we're going to do the observed value minus the expected value, and then square it, and then divide by E again. That E comes in there twice. And then we're just going to add all of those up. So those are going to be the steps that we're going to make the spreadsheet do. So let's share that screen. Here's my desktop. Go ahead and share. All right. So you should be looking at, and I've just gone ahead and made a little spreadsheet for example 11-3. There it is. And you can see I've built a little table for the frequency and the categories going across. Make that look nice. And then I've got the observed frequencies and expected frequencies. So that's what's going to be in each of these rows. In all of row 2, we're going to have the observed values. And in row 3, we're going to have the expected values. And then here are the 3 steps that I described. We're going to do O minus E, and then square that, and then divide by the expected value that's going to be found in this row here. And then after that, we'll just add up this whole row, and that will be our test statistic. All right, so I have the information right in front of me on the iPad, so I'll just tell you what it was. First of all, the expected frequencies, since we had 100 and all of these are percentages, then that's actually really nice. We'll just do the sample size 100 times each one of these percentages. And so that gives us that numerical value. 100 times the 74% is just going to be 74. Or another way to say it, 16% were supposed to be homicides. And so 16% of 100, that would just be 16 deaths. Kind of morbid subject, I guess. And then the observed values. So she looked at her district during 1 year, and there were 68 accidental deaths, 27 homicides, and 5 suicides. Okay, so the way that we're going to get the spreadsheet to do these steps, in this row, we want to do the observed value minus the expected value. So I'm just going to type equals, and then this square minus this square, and enter. So 68 minus 74 is -6. All right, for this row, we're going to just take that value and square it. So I'm going to take what's in this square and raise it to the second power and hit enter. So -6 squared gives us positive 36. So that's as we expect. And then in this last one, we're going to take the above square and divide by the expected value. Okay, so we'll go ahead and copy and paste each one of these. Let's see if I can do it fancy. Copy and paste all of those formulas across those 3 rows all at once. Okay, and there we have it. Yeah, you can see all of those calculations are done correctly. Just make sure that you're looking at your spreadsheet, in the correct way. And now finally, I'm just going to say the sum of these 3 values. So I'll just say this is equal to this plus this plus this. So I've got B7 plus C7 plus D7. And that gives me a test value of 10.549. We'll round it to that. Okay, so let's stop that share. It always takes a minute, but let's go back to the iPad so we can write that down. Share that again. I think it's sharing, maybe it's sharing. It's thinking about it. Okay, do screen mirroring. It's always fun on these Zoom meetings, I guess. Okay, so what we should be seeing here for step 3, we did this calculation, our chi-squared value, it worked out as 10.549 is what we said. Okay, so what does that mean? That means that we are way over, actually we'd have to go a little bit further and we would be way over here. This is our test statistic. So that's where 10.549 lands. So you can see that is well inside the rejection region. So in step 4, we'll make the decision and we reject the null hypothesis. And then the conclusion is that we've gathered enough evidence to say that this observed frequency distribution is different than the stated frequency distribution. And it'll take me just a while to write that. There is sufficient evidence to conclude there is a difference between what we observed and what we had expected. Observed distribution and the expected distribution. Okay, and as soon as I can get finished writing that, we'll be finished with this problem. Okay, so just to reiterate this, our test score was way off the charts, so we will get rid of this. So we found enough evidence to say that this does not fit with the expected distribution. And let's pause that, come back to the meeting. And that's it for today. We're not going to go further in chapter 11, section 1, the test for normality. We can go ahead and skip that. All right, so that's it for today. Good afternoon. I'm going to go and eat my lunch now. It's actually late morning. All right, goodbye.